Now, a trigonometric identity is an equation that's true for all values of the variables. Now, we've already gone through quite a few of them. In fact, here we have a handy page full of all of them. Tangent is sine over cosine. Cotangent is cosine over sine. Secant is 1 over cosine. Cosecant is 1 over sine. The basic Pythagorean identity is sine squared plus cos squared equals 1. If we take this and divide throughout by cos squared, you get tan squared plus 1 equals sec squared. If you take this and divide through by sine squared, you get 1 plus cotangent squared equals cosecant squared. I always have trouble remembering these, I have to admit, because it's tan or cotangent squared plus 1, but I always have trouble remembering which these are. In any case, I think this is more convenient, largely because generally if you're going to prove an identity, use the ratio identities to turn everything into sines and cosines. There are what are called parity identities, whether or not a function is even or odd. Cosine and secant are even, meaning that it takes a negative inside the parentheses and absorbs it. Cos negative theta equals cos theta. Sec negative theta equals sec theta. Sine, cosecant, tangent, and cotangent are what are called odd, meaning that they transmit the negative sign. So sine of negative theta equals negative sine theta. Cosec negative theta equals negative cosec theta. Tan negative theta is negative tan theta, and cotangent negative theta is negative cotangent theta. Then there's a whole business about cofunctions. Cosine of a sine is sine of pi halves minus theta. This is the complement of the angle theta, so cosine of angle is sine of co-angle, and vice versa. Sine of theta equals cosine of pi halves minus theta. Tangent and cotangent are related like that, tan and co. Secant and cosecant are related like that. Trig function of theta equals cotrig of complement of theta. Now, okay, even this section is a little unusual. In the homework, they ask to prove such and so. And that means, unlike most of the other books in this problem in this course, I will ask you in the homework to show all steps, because it's the steps which are the actual math involved. I mean, so to prove an identity, A is identical to Z. This 3 lines means identical. You could go by direct simplification from one to the other. You start with A, simplify it to B, simplify it to C, simplify it to D, dot, 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 and finally wind up with Z. So A is identical to Z. Another way is you take A and Z and you simplify them by steps to the same expression. That implies that A is identical to Z. So for example, prove one of the trig identities. 1 plus tan squared is identical to sec squared. Well, I start with the left side. 1 plus tan squared. 1 is cos squared over cos squared. Tan squared is sine squared over cos squared. Okay, we have adding 2 fractions with the same denominator. Put them over the common denominator. Underneath cos squared plus sine squared. But cos squared plus sine squared is 1. So we have 1 over cos squared. That's sec squared. That's the right-hand side, and QED. The identity is proven. QED is a fancy phrase in Latin, meaning quod erat demonstrata, meaning which was to be demonstrated. It's sort of a bit of math nerdy punctuation. Okay, I'm done. Now here we have 1 plus tan over 1 minus tan. Prove that's identical to cotangent plus 1 over cotangent minus 1. Now I'm going to start with the left side and convert it and simplify it to an expression. I'll start with the right side and convert it to the same expression. So 1 plus tan over 1 minus tan. Tan is sine over cosine. So 1 minus sine over cosine over 1 minus sine over cosine. Now I'll rescale this fraction. I'll multiply above and below by cosine. 1 times cosine is sine is cosine. Sine over cos times cos is sine. 1 times cos is cos. Sine over cos times cos is sine. So we have cos plus sine over cos minus sine. That's the left side. Right side, same deal. Cotangent plus 1 over cotangent minus 1. Cotangent is cosine over sine. So you have cos over sine plus 1 over cos over sine minus 1. Multiply above and below by sine, and it turns into cos plus sine over cos minus sine. These are identical. Therefore, these were identical. Therefore, left is identical to right, QED. So here are 2 methods to prove an identity. Just simplify one to the other, or simplify both ends to the same thing. Now, here is how not to prove an identity. I always feel a little bit sketchy when I tell you what not to do, because there's a perverse tendency for people to remember that I said something and therefore they do it. No, 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 don't ever do it this way. The way not to prove an identity is to assume that it's true, then by particular manipulations yield an identity. So you assume the identity and you go by steps until you derive an identity. But that doesn't work. You can start with false statements and manipulate them to imply a true statement. For example, if you assume that -1 is 1, which is false, then if you square both sides, you get 1 equals 1, which is true. So just because a long line of argument yields the truth doesn't mean the initial assumptions were themselves true. That doesn't work. Here we go. Now, here's some examples. Prove an identity that 3 sine squared plus 4 cos squared equals 3 plus cosine squared. All right, here we go. Left side of 3 sine squared plus 4 cos squared. Break 4 cos squared into 3 cos squared plus cos squared. 3 sine squared plus 3 cos squared plus cos squared. Okay. Then, these two terms is a common factor of 3. So this is identical to 3 times sine squared plus cos squared, all that plus cos squared. Oh, but sine squared plus cos squared is 1, so you get 3 times 1 plus cos squared. That's 3 plus cos squared, which is the right-hand side, and we are done. This has been proven identical to that. Left is identical to right. And here we have the expression, an identity, tan theta minus cotangent over tangent plus cotangent. Prove that it is identical to sine squared minus cos squared. All right, left side, we rewrite tan as sine over cosine here and here. Cotangent is cosine over sine here and here. All right, now we simplify this fraction by multiplying numerator, the denominator, by sine times cosine. Well, okay, sine over cos times sine cosine. Cosines cancel, we're left with sine squared. Minus cos over sine times cosine. Sines cancel, left with a minus cos squared. Sine over cos times sine cosine. Cosines cancel, left with sine squared. Plus cos over sine times cosine. Sines cancel, left with cos squared. So sine squared minus cos squared over sine squared plus cos squared. But this denominator, sine squared plus cos squared, is identical to 1. So we make that replacement. And then anything divided by 1 will just be the numerator, sine squared minus cos squared in this case. That equals the right side, and therefore the left is identical to the right, and the identity is proved. Okay, that's it for that. Next time we'll be going over what are called the angle addition laws. These are identities involving cosine of a sum and sine of a sum equals a combination of cosines and sines of alpha and beta. We'll see more about that next time.